This video will show you how to perform multiple regression. In this example, we have weekly gross revenue, television advertising, newspaper advertising, and online advertising. In case of simple regression, we investigated the relationship between one dependent and one independent variable. But usually in practice, dependent variable is affected by more factors, by more independent variables, which can be included in regression as explanatory. So for example, in this case, weekly gross revenue will be dependent variable, and we have three independent variables: television, newspaper, and online advertising. And we are interested how these three factors influence dependent variable weekly gross revenue. So we are going to estimate multiple linear regression. This is the functional form. We go to data analysis, select regression. Range of dependent variable will be weekly gross revenue. Range of independent variables will be the range of all three variables at once. So in case of multiple regressions, it's necessary to select all variables, all explanatory variables as one field. I did not select it labels, so I will not check labels on. And select output range. Where are we? Here it is. Output range. There it is. So that's the output of multiple regression. It differs from simple regression in number of estimated regression coefficients. So once again, strong correlation, coefficient of correlation is close to 1. Estimated regression function explains 93% of variability of revenues. Function is significant. P-values are very important in case of multiple regression, because you can decide using p-value about significance of variable. In case of multiple regression, for example, variable x3 is not significant, which will mean that variable x3 does not influence significantly revenues and can be removed from this regression equation. Online advertising. So according to result, x1 and x2 are significant, which means television advertising and newspaper advertising influence dependent variable significantly. Online advertising is not significant. Here are estimated regression coefficients, and you can see if there would be no advertising, average value of revenue would be equal to 82. If x1 television advertising will increase by 1 unit, the average increase in revenue will be 2.32. If x2 newspaper advertising will increase by 1 unit, increase in revenue would be 1.29. In case of online advertising, if online advertising will increase by 1 unit, the average increase in revenue would be 0.08. But online advertising is not significant, which means it doesn't affect significantly. What does it mean that some variable is not significant? This is the point estimate of the influence of this variable, point estimate of regression coefficient. Here can be found interval estimate, and you can see interval estimate of this parameter could be from minus 0.17 to 0.32, which means that it's possible that regression coefficient could be equal to 0. If regression coefficient could be equal to 0, then there is no influence of this variable to dependent variable, and we can simply remove this variable from this regression function. So these are our regression coefficients, and if we would write down or fill in these regression coefficients to this function, so we estimated function 82 plus 2.31 plus 1.29 x2 plus 0.08 x3. That's the estimated regression function. In this case it's multiple regression. Online advertising was not significant, so if we would like to remove online advertising from this function, we could continue and estimate one more regression using just significant explanatory variables. So I will select another output, significant explanatory variables, and in this case, as we mentioned before, all variables are significant, estimated function significant. That's here are estimated regression coefficients. If you compare R-square value, 0.93 is higher than 0.91, which would suggest that this function could be a little bit better. But adjusted R-square is adjusted by number of explanatory variables. So if we would compare adjusted R-square 0.88, 0.886, you can see this one is slightly higher. So in this case, this function is better, significant. All variables are significant. So usually in practice, if some explanatory variable is not significant, we should remove it from regression and re-estimate regression function without non-significant factors. And that's actually all about multiple regression function.